delta loop antenna, as the name implies, has the shape of a Greek alphabet delta. You can see it is an inverted triangle, that is delta. This is a full wavelength antenna. The total length of the loop will be a full wavelength for that particular band. And the impedance will not match the usual impedance of the coaxial cable of 50 ohms. It will be almost 4 times higher. That is why a conversion is needed with a matching transformer, which we sometimes call as a balun. 4:1 balun is needed for matching the impedance of the full wavelength delta loop antenna to a coaxial cable. For usual dipole antennas, the impedance mismatch is not so much. That's why 1:1 balun is used for suppressing the common mode current. And this is one mode of mounting the delta loop with balun at the lower port. You can also have balun at the side, but this is the more commonly used one, especially for high frequency HF antennas. These two high supports will be there, and you can have two pulleys on either sides with a weight here. The advantage is that with the weight of this balun, delta loop can sag down. So that can be prevented by having pulley and weight mechanism. The upper part can be almost horizontal. And this is a method of mounting with two supports. I didn't have space to mount a full wave loop antenna for HF. So my experiment was with a VHF. This is a VHF delta loop. Made it very simply. This one is not delta loop. This is, you can understand that it is a Yagi type of antenna. It's a Moxon Yagi for satellite operation. I have mounted on a different mast. So this is my experimental VHF delta loop antenna. Advantage of delta loop is that it has very low noise floor because it's a closed loop. Noise level is very low for a delta loop antenna. I have experienced that with my VHF delta loop also. Ideally, I would have needed for HF because for HF I have S9 of noise level on most bands. So having a delta loop would have been ideal, but I do not have space enough to mount a delta loop. Then when I use the VHF delta loop, I used to rotate it. That is, using this PVC pipe as an anchor, I used to rotate it because the delta loop has a slight directivity in the plane perpendicular to the loop. So when I used it for satellite communications or VHF repeater communications, I used to rotate this delta loop manually in order to orient it towards the direction of the satellite or the VHF repeater. But that is not practical for an HF unless you make it for a higher band like 10 meter. Maybe you may be able to rotate it in the direction of the stations which you would like to receive. When I made my VHF delta loop antenna, I didn't have a balun. So what I did was I used a matching section. This is a matching section of 75 ohms cable. For feed line I am using RG213, that is 50 ohms. Here I am using 75 ohms matching section, which is a quarter lambda section of 75 ohms cable can match this VHF delta loop instead of the 4:1 transformer. So I could use this antenna with my cable, RG213 cable, and connect it to the VHF radio. I could easily use that VHF delta loop antenna for contacts through local repeaters, and this is one of the advanced things. I could use it also for receiving. This is the slow scan television image, SSTV image, being received in my mobile phone through the radio. This is my IC2730 radio. You can see that almost full scale deflection of signals on 145.800 megahertz from International Space Station is being received. That's because they use about 25 watts of power while transmitting SSTV from a height of around 400 kilometers at the space station. This is the image which I received, and this is Robo 36 app. Receiving slow scan television image is quite easy. All you have to do that, tune to this frequency, turn your antenna in the direction of the satellite. I have told you I have positioned the delta loop almost so that the broadside is along the path of the satellite. For the path of the satellite, you have to look at websites like N2YO, November 2 Yankee Oscar website.com, and find the path direction and orient the antenna in such a way that the broadside is along the direction of path. And this app can be downloaded in your mobile phone and switched on. While the app is on, all you have to do is keep the mobile phone in such a way that the microphone of the mobile phone is in the direction of the speaker of the radio, and this will start decoding. A buzzing noise will be heard during the decoding when the radio is receiving that sound from the International Space Station. This was another experiment with the same delta loop antenna. This is the n2io.com that I was mentioning, which is showing the direction of pass. Of course, it's a high elevation pass going very near my home. That is, the maximum elevation will be quite high, so that it will be almost overhead passes. Only such passes can be used for such non-directional or minimally directional antennas. Otherwise, you will need Yagi antennas pointed in the direction of azimuth and elevation. Here I am not using any elevation because this can't be moved up. While the other Moxon Yagi, I rotate to the direction of the pass when needed. There also the elevation is fixed because I do not have a elevation changing mount over there. And this is the site which is used for tracking Doppler. Argentinian AMSAT web page which is used for tracking Doppler. When the satellite is there, you will see this clock face. This will rotate in the direction of the satellite movement. And for Doppler frequencies, you can see the Doppler frequencies, uplink and downlink, you can see. This is an attempt to contact through the crossband repeater of space station. You can see the frequency is different. Uplink is on 145.990, downlink on 437.800. This 10 is extra for Doppler correction when the satellite is approaching you. When satellite is going away from you, this will be below 800. That is to illustrate how I use the same antenna for a single contact through the International Space Station as well. Directivity and gain of the delta loop antenna can be increased by adding additional elements, just as in Yagi antenna. This is a reflector element which has been added on a boom. This is the driven element. You can see the transformer here. 4:1 transformer you can see here. You can add any additional, of course this has to be slightly larger in dimension compared to the driven element. The problem for directional delta loop antenna, as you would have guessed, is that the size for VHF and UHF maybe size is reasonable, but for HF, except probably for 10 meter, it will be very difficult to have such antennas full loop at a height on a boom. So this is one of the pictures I have seen of the directional delta loop antenna. So in this directional delta loop, there will be higher gain and higher directivity. As this is a reflector, more signal will pass in this direction with a better front to back ratio. And naturally, when the signals are directed in one direction, signals in opposite direction, in this direction will be lesser, and gain will be more in this direction. That is a directional delta loop antenna, but this is used very seldom, especially on HF bands, because of the huge size which is required. And in case of VHF, most popular is VHF and UHF, the usual Yagi antennas.